Chapter 1 PreCalculus Review. Don't forget, this review paper is due Tuesday as you guys walk in to take the chapter test. So make sure you review every questions. Go through the process of I'm going through on these videos. Ask any questions you may have on Monday. So now let's take a look at example 1 through 3. You're given the functions asked to be compared to the parent functions. Identify each of the transformation information, then use that information to help you graph on the graphing paper. First equation, you see that the x is being raised to third power. So the third power raised to the third power is giving us the clue it's going to be a cubic function. So the parent function is y equals x cubed. What kind of transformation do you see? Every time I remind you, make sure you rewrite it into x minus. So in order for you to rewrite this equation, it will become negative x minus negative 2. So that way you won't change any of the given equations. Minus negative 2 means that it's going to move left 2 down 1. So the subtracting 1 is like a standalone number. That gives you the clue of moving the function up and down 1. And then the negative 1 multiplying to the whole function is the 1 of our a. When a is less than 0, it means it's reflected across the x-axis. So the transformation will compare to the parent function will be left 2, down 1, reflect across the x-axis. Now I'm ready to plot the graph. So first identify your initial point. Left 2, down 1. So we are going to start with negative 2, negative 1. And then because of the reflections, I have to count left 1, up 1, left 2, up 8, right 1, down 1, right 2, down 8, instead of the original parent functions. And I have all these 5 points, so I can connect them to make my graph. So it should have an opening. It should have like a stretched S. So that's question number 1. Question number 2. You see the 2 bar across the variable x. So that's going to be absolute value functions. Y equals the absolute value of x. And what kind of transformation? It's already in x minus format. So it's going to be right 1, down 3 with a vertical stretch factor of 2. So right 1, down 3. Identify our vertex points to be located at 1, negative 3. Vertical stretch factor of 2, that means the slope of this absolute value is going to be 2 times faster than the original. So with all this information, you can quickly make a graph. And the absolute value functions should have the shape of a distinctive V shape. Number 3, the square root. Y equals the square root of x. That's our parent function. And then the transformation would be left 1, up 4, with a vertical stretch factor of 2, then reflected across the x-axis. Again, because the whole function is being multiplied by negative 2, the negative means that it's being reflected across the x-axis. So first identify your starting point, left 1, up 4. And then everything is being reflected across the x-axis. So imagine there's the new x-axis. Vertical stretch by a factor of 2, so your function should go down 2 times faster. Question number 4. Find the slope-intercept of the equation of the line that passes through negative 2, 6 and has a slope of negative 3. So we're given the information of a point and the slope. So I'm going to directly plug it into the point slope form, which is y minus y1 equals m times x minus x1. So plug in the given values. What do we have? We have the information of y1 equals 6. The slope is negative 3. And the x1 is negative 2. So again, when you subtract the negative number, make sure you put a parenthesis. Then try to put that in slope-intercept form. We have y minus 6 equals negative 3 times x, which is negative 3x, minus negative 2 become positive 2. So negative 3 times positive 2, that's negative 6. Then add 6 to both sides. We have y equals negative 3x. And definitely plug the points negative 2 back into the equation. The 6 equal to negative 3 times negative 2. It checked out, so that's correct. Our answer is going to be y equals negative 3x. Number 5. Find the slope-intercept form of the line that passes through negative 5, negative 1, 5, and 5. So first we need to look for the slope. What's the slope definition? So change in y over change in x. I'm going to take 5 minus negative 1 over 5 minus negative 5, which gives me 6 over 10. And I can reduce that down to 3 over 5. Again, change in y over change in x. So 5 minus negative 1 over 5 minus negative 5. Now we have the slope. Next, I'm going to pick a point. Which point do you like? I like to work with positive numbers, so I'm going to pick the 5, 5 as my point information. So y minus 5 equals 3/5 of x minus 5. So same procedure as before, as the example number 4. Y minus 5 equals, so distribute the 3/5 to both terms, 3/5 of x minus 3. Add 5 to both sides, so our final equation is going to be y equals 3/5 of x plus 2. And definitely check your answers by plug the function plug the points back into the equation. Number 6, find the slope-intercept form of the line that passes through negative 3, 2, and is perpendicular to x minus 1 equals 0. So this one, instead of calculating using the slope-intercept form, I would like to take a look at x minus 1 equals 0. What does it represent? So as I add 1 to both sides, I have x equal 1. How do I graph this line on the graphing paper? X equal 1, so that means the line would have to pass through x equal 1. And the line perpendicular to it and passes through negative 3, 2. Negative 3, 2. So what would be a line perpendicular to a vertical line? It would have to be a horizontal line. And horizontal line, since it passes through negative 3, 2, you would have a y-intercept point of 2. So basically, it would be represented as y equals to 2 with a slope of 0 because it's a horizontal line. Find the slope-intercept form. Number 7. Find the slope-intercept form of the line that passes through negative 2, 1 and is parallel to 4x minus 2, 3, 2y equals 3. This time you have to make sure the given equation 4x minus 2y equals 3 be converted into the slope-intercept form in order for you to read out the slope information. Not because you are given a line, then the numbers in front of your y is going to be your slope. You have to make sure it's in the slope-intercept form. So let's do that first. 4x minus 2y equals 3. So how do I find the slope-intercept form? Rewrite into slope-intercept form information. I'm going to subtract 4x to both sides. And then I'm going to divide both sides by negative 2. So now I know the slope is going to be 2. Parallels. So a line parallel to this line would have the same slope. And it's passing through. So I'm given the point negative 2, 1. So y minus 1 equals 2 times x minus negative 2. Put that in slope-intercept form. Distribute the 2. So I have 2x, 2 times x, minus negative 2 again, become positive. So that's 2x plus 4. Add 1 to both sides. Reduce this down to y equals 2x plus 5. Question number 8. Sketch the piecewise functions. So take a look at letter A. You're given the piecewise functions. And then the domain information. So I've mentioned this several times. The piecewise function is nothing more than you are specifying the domain with the given information of the domain. So first, make sure you put on the information for the dividing lines. And this time, because our dividing line for letter A is equals x equals negative 1. So I directly put down that line in red. To the left, so less than or equal than -1. So to the left means that it's going to be a linear equation. How do I graph the linear equation? The easiest way would be just directly plug it in the points. When x equal to -1, so 2 times -1, I have -2. -2 minus 1, that's -3. And then I can use the information of the slope. Slope is 2, so I'm going to go left down 2. This way I can make the graph for my linear equations. Anything greater than -1 would be, so this is going to be a parabola, a quadratic equations. X squared plus 2. So again, I can directly plug it in the points, or if am I able to identify, this is basically the quadratic equation being moved up by 2 units. So starting from 0, 2, I count left 1, up 1, and then because of this point, I do not include the -1, so I have to put it as an empty circle. Right 1, up 1, right 2, up 4. So I'm using the transformation of the parent function to help me quickly make the graph. Letter B, f of x. Again, the dividing line is -2. So I put down x equal to -2 in red. So anything less than -2 would be a constant 3. So it's going to be a horizontal line parallel to the x-axis. Again, it would have to be stop at x equal to -2. Anything greater than -2 becomes the linear equation 2x plus 1. So I directly plug it into the equation. 2 times -2, which is -4. -4 plus 1, that's -3. So it does not include the endpoint, so it has to be an open circle. With a slope of +2, so I have to go right 1, up 2. This way I can connect the line, connect the dots to make my line. Was that easy? I think so. Letter C, dividing line x equal to 1. So again, x equal to 1 in red. So anything less than 1, it's going to be the quadratic equation x squared minus 1. So x squared minus 1 means that everything being moved down by 1 unit. So 0, -1. Right 1, up 1. Because it includes the endpoint, so I definitely put that as a solid circle. Left 1, up 1. Left 2, up 4. So I can connect the dots to complete the quadratic. To the right, x greater than 1, it's going to be 3 minus x. So when x equal to 1, 3 minus 1, that's 2. So this time, be sure to put an open circle with a slope of -1. So next point would be 2, 1. Now I can connect the dots to graph the line, linear equation. So my graph may be not very accurate because I'm drawing it by hand. If you're using a straight edge, a ruler, your result will be better than mine. Question number 9. Determine if the function is even, odd, or neither, and justify your answer. Letter A, you have x cubed minus 1, x cubed. 3 is an odd number, but the subtracting 1 is a constant, so moving the functions down by 1 will make the function not symmetric, not reflection across the point of origin, so it's no longer an odd function. So our answer for this one is going to be neither. Letter B, x cubed minus x. So x raised to the third power, 3 is an odd number. X, you do not see the exponent, but it's actually x raised to the first power. So 1 is an odd number. So this will make the function an odd function. Letter C, x squared minus 1. X squared is an even power, 2 is an even number. Minus 1, moving everything down by 1, it will still make the function reflect across the y-axis. So this is still going to be an even function. Adding a constant, subtracting a number will still make the even functions reflect across the y-axis. Letter D, x squared minus x. So 2 is an even number. X raised to the first power x, 1 is an odd number. This will make the function neither, it's not going to be an even function, nor an odd function. Question number 10. You are given two functions, f of x and g of x. You're asked to do the calculation. So letter A, again, on your textbook, it's written like this, but personally, I like to write it in the format of f of x plus g of x. So this is function addition. So directly plug it in. What's f of x? So we are given x plus 1. What's g of x? That's x squared minus 1. So try to put it in standard form. So that's going to be x squared plus x. Letter B, f of x minus g of x. When you subtract, make sure you put a parenthesis. So we have x plus 1 minus x squared minus 1. Distribute the subtractions, the minus sign, to both terms. So we have put that in standard form, we have negative x squared plus x plus 2. Letter C, function multiplications, f of x times g of x. And we have the f of x as x plus 1, g of x as x squared minus 1. So using the FOILs, x times x squared times 1, negative 1 times x, and negative 1 times 1. Letter D, f divided by g of x. So we have a linear equation divided by a quadratic. There's nothing much I can do about it. It has a lesser degree. Numerator has a lesser degree than denominator, so I think that's it. But we have to specify the restrictions. When you have something on the denominator, make sure you exclude the x values that will make your denominator equal to 0. So x squared minus 1, you can factor it into x plus 1 times x minus 1, which makes the restriction for your denominator, x cannot be equal to 1, x cannot be equal to negative 1. Last one, composite functions, f of g of x. So you are getting the information from g of x as the input to the f of x. Again, do not overthink. Whatever you are given, just directly plug it in. So g of x is given as x squared minus 1. That becomes the input to f of x. What's our f of x functions? So it's x plus 1. So basically, I'll just replace the x with x squared minus 1. So our final answer for letter E is x squared. Question number 11. Find two functions f of x and g of x such that. So in order for the functions to go through the composite functions, make sure the order of operations are being observed. Parentheses, exponent followed by multiplication additions, then the last one is addition and subtractions. So for letter A, I have g of x equals to 3x plus 2, f of x equals x squared. Letter B, g of x equal to x plus 1, f of x equal to square root of x. Letter C, g of x equals to 2x minus 1, f of x equals to 1 over x. Number 12. You are given the square root functions and you are asked to find its domain, range, inverse functions, and the domain range information for the inverse functions. Then asked to graph the functions f of x and its inverse functions plus the reflection line y equal x. So the information we have, domain of f of x is going to be x greater or equal than negative 3. Range for the f of x is going to be y greater or equal than 0 because it's a square root function. So make sure all the values coming out from the square root would have to be positive. All the numbers inside would have to be positive. Otherwise, it's going to be imaginary, which does not exist. For the inverse functions, so f of the negative 1 does not mean that it's being raised to negative 1 power. it means that it's finding the inverse function of f of x. So the inverse function is x squared minus 3. Domain is going to be x greater or equal than 0. Y is going to be greater or equal than -3. So again, inverse information as opposed to the original functions. They have this relationship. Input to output, output becomes the input. And I also put the graph down below. Letter B, that's a linear equation. So the domain would be real number. Range would be a real numbers. The inverse, it's going to be 1/2 of x plus 3/2. 1/2 of x plus 3/2. And then the domain. So inverse is also a linear equation. So the domain and range are also going to be real number as well. As I mentioned in class several times, you will be asked to show that the functions, as you input the functions into inverse functions followed by the original functions, you should get the original input. So make sure you demonstrate that you understand this concept. It's very fundamental information for us to move into our sections of the functions and its inverse. So make sure you practice these sections. And I wrote out all the information for these two particular examples. So plugging in the x into inverse functions followed by the original functions, you should get the input x itself. Or vice versa, if you plug the functions x into f original function first, followed by the inverse, you should get the x as the output. Number 13. So this time you are given a graph and you are asked to write out the equations. So first identify which categories, which types of function does it belong to. Then identify the transformation information. Then use the value for a, h, and k to write out the equations. So letter A, it's a distinctive V shape. It's going to be the absolute value functions. And then we see the vertex is located at, so where's the low vertex information? It's located at 1, 3. That means you have to move right 1 unit, up 3 units. And then as you see, it's reflected down. So it will have the information of -1. So the equation is going to be y equals negative the absolute value of x minus 1 plus 3. Number 2, it's a square root functions. And I have to move. So where's our starting point? I have to move left 3 down 2 units to find it. Left 3 down 2. And it's the standard square root functions. So my equation is going to be y equals the square root of x plus 3 minus 2. Last one, it's the parabola shape, quadratic. So y equals x squared as the parent functions. I have to move left 1 down 2 units to find its vertex. So the equation is going to be y equals x plus 1 squared minus 2. That wraps up our Chapter 1 review. Be sure to go over this information or this video as many times as you want. You can pause, stop, practice. Monday, we will have the class time to ask any questions you might have.